Now let's move to the second rule, the sum and differences. That's the second rule, the sum and differences. Okay, now according to this rule, I told you that the limit of a sum or differences is the sum or differences of the limit. Now let's say you have a function let's say you have a function limit f of n. Now we want to talk about sum. Now we want to talk about sum. So limit f of n plus g of n as n tends to infinity. Now according to this, you can see that the sign between function fn and function gn is what? Additional sign. That means it is sum. You understand? So now according to this rule, the limit of this function is equals to the sum of the limit. That means I'm going to have lim f of n as n tends to infinity plus limit of function g, function g of n as n tends to infinity. You understand? So that is the basic idea behind the rule. Now, because we have already said that let the limit of a function let the limit of f of n as n tends to infinity equals to f, and the limit of function g of n as n tends to infinity equals to g. So we are going to have f plus g. You understand? We are going to have f plus g. Okay. Now, according to the difference, we are moving to difference now. Difference means subtraction. You understand? So let's say we have limit of a function f of n minus the limit of function g of n as n tends to infinity. That means we are going to have limit f of n as n tends to infinity minus the limit of g of n as n tends to infinity. That means I'm going to have f minus g. Okay, so that is the basic idea between the sum and differences rules of the limit of a function. Okay, now let's look at example. Let's look at example of what we learned. Okay, let's say you are asked to, please pay attention. Let's say you are asked to take the limit of this function. Limit n plus 1 all over 5n, okay, minus 1 over, okay, minus 6 over n rather, minus 6 over n as n tends to infinity. Okay, let's say you are asked to take the limit of this function. Well, how do you find the limit of this function? It's simple. All you have to do, the sign between these two functions is what? A subtraction sign, which is difference. You understand? So you go back to the rules of limit, that the limit of the difference is the difference of that limit. You understand? So the limit of difference between two functions is the difference between the two limits. So we have to take the limit of each of the function individually. Okay, so for this I'm going to have something like this. Limit of n plus 1 all over 5n as n tends to infinity minus the limit of 6 over n as n tends to infinity. Now you see this question here that you see here, I can rewrite, please pay attention, according to the multiplication of a constant rule that we learned earlier. You know, multiplication of a constant is also part of the rules that applies to limit. You understand? So I can rewrite this limit as 1 over 5 limit of n plus 1 all over n as n tends to infinity. You understand? So now don't forget that n plus 1 all over n the limit is what? Is 1. You understand? So, you know, we've done it. If you take the limit, if you take the limit of n plus 1 all over n as n approaches infinity, you know that we're going to get 1. You understand? So I'm going to have, for this, I'm going to have 1 over 5 multiplied by 1. Now I'm dealing with the left hand side, you understand, which is this one. Now for this, I'm going to have limit of 6 over n. Pay attention. Limit of 6 over n will be 6. Limit of 1 over n as n tends to infinity. You understand? Now don't forget that if you limit 1 over n, the limit of 1 over n is what? 0. You understand? When I started this class, I explained what it means, the meaning of this. You understand? And the value we tend to approach is 0. So we set 1 over n, the limit of 1 over n as n approaches infinity to 0. You get what I'm trying to say? So for this, I'm going to have minus 6 multiplied by 0. Okay? So that means I'm going to have 1 over 5 minus 0, which is what? 1 over 5. Okay? That is the limit of the function. Okay? I'm very sure you understand. That is the limit of the function. The limit of this function is 1 over 5. If you still don't understand, maybe you should kindly reverse the video, okay? Kindly reverse the video. It's simple, okay? So that is the limit of the function. And if you want me to reiterate, you can let me know in the comment section. Now, so you can see the application of the difference now. The limit of the difference of the function is the difference of the limit of that function, okay? And that's the rule that we apply here. So I will give you another example that I want you to try. That one will be based on sum, okay? Let's say you are asked to take the limit of this function. Let's look at sum. Okay, let's say you have to take the limit of 7, okay, limit 7 over n, okay, 7, oh sorry, 3 over 7n, 3 over 7n, 3 over 7n plus 4n plus 4 all over 5n as n tends to infinity. Now, look at this question. You can see that the sign between the function that we have in the bracket is an additional sign. So we use the additional rules of the limit of a function. And how do we go about that? Well, according to this rule, the limit, the sum of the limit of the sum of a function is the sum of the limit of that function. Okay, so we just approach it just like we did for the differences. So for this, I'm going to have limit 3 over 7n, 3 over 7n as n tends to infinity plus limit 4n plus 4 all over 5n as n tends to infinity. Now, for this, I'm talking about this now. I'm going to have, according to the multiplication of a constant, you can factorize 3 over 7 out. So I'm going to have 3 over 7 limit 1 over n as n tends to infinity, as n approaches infinity. And for the second one, please pay attention. You see 4 over n, 4n plus 4 all over 5n can be written as 4 over 5 into bracket n plus 1 all over 5. All over n. It's just like I factorize 4 then I bring 5 outside. Okay, so for this I'm going to have 4 over 5 limit of n plus 1 all over n as n tends to infinity. Do you understand? Okay, now from this point we can actually take the value of the limit. If you limit 1 over n as n tends to infinity, what will be the answer? The answer will be 0. You understand? Okay, so I'm going to have here 3 over 7 multiplied by 0. Okay, 3 over 7 multiplied by 0 plus. Okay, now we're going to have 4 over 5 multiplied by, now if we take the limit of n plus 1 all over n as n tends to infinity, you're going to have 1. You understand? So I'm going to have this multiplied by 1. Okay, and if you are not sure, you can take the limit by yourself. To take the limit of a function that looks like this, all you have to do is that just divide both the numerator and the denominator by n, just like what we did in in the previous example. So the final answer to this question is what? That will be 4 over 5. Okay, the limit of the function is 4 over 5. If you get it correctly, kudos to you. Okay, so that is the application of the sum. You understand? Now there are many other rules, you understand, that we're going to talk about. But before that, I want to give you I want to try this question. It's also on the sum of the limit. I want to try this question. Evaluate the limit. I want to try this question. Evaluate the limit as n tends to infinity. Okay, I want to try this question. Okay, make sure you try it and let me drop your answer in the comment section. That's the work. I want to try it. Just approach it. Do it using the method that I use here. You're going to arrive at the right answer. Okay. Now, having understand the sum and the differences law, let us move the product and the quotient. You understand? The product and the quotient law. Okay.